pretty good here. Never use the word pretty good. Use good or bad. My way. Should be great.
Wow, these are great. Great windows. 0.23 U factor. Are these triple glaze or they have heat mirror?
Triple glaze.
Triple glaze. Yeah, that's incredibly good. That's basically an R4.
Right.
An R4 window.
And what I'm trying to remember, energy code for a single family in this area is
0.35.
0.35, right? So that's about
30% better than code.
Right.
Solar heat gain coefficient is basically a measure of how much radiant heat will be emitted
from the sun. How much gets through or doesn't.
Mm-hmm.
So in
the
this
lower
case,
the number, the better.
22% is going to get through, but 80%
is going to be reflected.
Right.
Based on the coatings and all the glass in here.
Right. And as I understand it, it's sort of like what they call a second surface, so the inside surface of the outside piece of glass, because it's that way it's inside the vacuum, it's protected, has essentially a layer of sort of metal molecules. So if you're a sun's ray, it's like you're seeing this metal, it's like a little mirror.
Right.
And so we can still see light through it, visible light, but the heat gets bounced back out. And the reason we're doing that is so that we can keep the sun's heat out, because we want to actually keep the house cool in the summer. Because the sun will overheat it, particularly on like the west windows. The visible transmittance is how much visible light gets through, right?
Right.
And clear glass, I'm trying to think, is about 80% for double glazed, and we're at about 0.35, so somewhere on the low side. It might be a little darker in here.
Good numbers. We're putting on the straight flash at the jams, just to provide some self-sealing for fastener penetrations of trim, as well as closing off the perimeter of the window.
Thank you. Uh-oh. Did the ultimate sin. Touched it.
Is this different from any other kind of peel and stick?
Yeah, this one has the butyl component. Basically makes it more sticky. The shingle lapping all the pieces. We're still going to have a head flashing that goes over this.
Metal head flashing.
A metal head flashing that will kick water over it. I would say using the straight flash rather than the Tyvek tape is an improvement over most commercial construction. Mm-hmm. Most commercial construction that we do will just use the Tyvek tape to tape the flange, but using the straight flash, using a 4-inch straight flash, it is I would say a step better. Tyvek tape is specially formulated to stick to Tyvek. It actually is. It looks like packing tape. It smells like packing tape. But it's more durable and sticky than packing tape. So there actually is a difference. So let's go inside. We're going to finish up with the spray foam on the inside, and I think Greg may have gotten started on that already.
Okay.
And then we're also going to do a sealant joint across the base of the window at the bottom to complete the air seal around the whole window. We're not going to spray foam the bottom because if water collects there, we want it to be able to get back out.
So there's a little cavity underneath there.
Right.
Okay.
Yep. Between the window and the Tyvek.
In the rough opening, right?
Right.
And
so around most windows and doors, they'll specify a window and door grade foam. If it were a high expanding foam, it could it could actually exert a lot of pressure against the window frame and then cause problems with the window operation. Well, the reason we don't stuff the bottom full of foam is because if that's where water is going to collect, we need to allow it to get back out. So we're just going to seal the bottom with sealant. There's a little gap underneath the window there.
this window is totally sealed from the weather, right?
Yes.
We've got the flashing at the bottom, the sides, the top. We've caulked it. We've allowed the water to get out. It's all set. Is rain going to get in here?
We don't. We don't know until we test.
Okay.
So
we certainly hope not, right?
Right. That's
Okay.
the idea is that we've installed it in a way that rain can't get in. If rain gets in, typically, if it's going to get in at this point, it's going to be through the frame.
Okay.
Like a frame corner breaks or a sealant joint fails at the frame corner.
Which can happen, right?
Yeah, that's
rain
where
can
we
actually go through here. But then
Yeah.
again, it'll hit that sill and come back out.
Right, which is why we provided the sub-sill drainage to come out here behind the bottom portion of the window. I can just barely get my finger behind that, and that's enough drainage space to allow water to come out of there. Testing a window at this stage means you're testing it at the worst possible exposure conditions. There's no siding on, there's no trim, there's no sealant, there's nothing to protect the last line of defense, which is the weather-resistant barrier. So if the window passes a water penetration and resistance test at this stage, then we know that it's going to pass once we have all the siding on and it's fully protected. We like to test at this stage because it's the worst condition, and also because we're testing the window, and we're also testing the window to wall interface. So we're seeing if water comes through the window. That's one aspect of the test, and then we're seeing if water comes through where the window and wall meet. And so we want to make sure neither of those cases happen.
And the reason for all the attention on windows is that's where the failures tend to be, right?
Exactly. Most of the failures, aside from roofs and roof leaks, it's all typically window corners or just some water's getting in through a failed sealant joint around a window, and we want to provide a mechanism to get out.
Okay. So this is commercial quality construction applied to a house.
Mm-hmm.
Okay, that's great. And so we're going to test it.
Yes.
That should be exciting.
Yeah.
Okay.
A lot of water.
And if it passes the test, then we've succeeded. But we're actually trying to make it fail. We're trying to see if we can actually get water through here.
Right. Okay. Right. Yeah. We of course, I've done many installations like this, hundreds if not thousands at this point, and have tested hundreds. And if it fails because we've missed some little point. We've missed like an air leakage spot, or we have a fish mouth in the sealant or the tape or something like that. So.
And this is our first window, so we want to make sure we get the first one right, so we get them all right.
Right.
Okay.
Exactly.
Good.
So we're going to simulate wind-driven rain. We're going to spray water on the outside of the window, and we're going to suck air on this side with our trusty little shop vac at a specified rate. And so it simulates wind-driven rain conditions. So like the wind's blowing really hard and the water's hitting the window. We're just making sure we get as good a seal as possible. It doesn't have to be perfect around the window, but we want to be able to hook up the apparatus so that we can get the negative pressure that we need. For a DP50 window, design pressure 50 window, the test pressure in the factory they test these at for water penetration resistance is 7.5 pounds per square foot. In the field, you reduce that number by 2/3, or you reduce the number by 1/3, so you end up with 2/3, so we're back to 5. A 50 is a pretty decent design pressure. That means it's got to be a pretty strong window to withstand that. Like most 1, 2, 3, even 4-story buildings typically will have 20 to 30 PSF would be the design wind pressure. This window's probably an R50, R meaning residential, 50. If the design pressure they use is 50, then it's an R50 window.
So 50 is pretty darn good, right?
It's very good.
Somewhere on the low side. It might be a little darker here.
Uh-oh. The ultimate sin touched it.
Tyvek tape is specially formulated to stick to Tyvek.